Hello, everyone. Present myself, okay? Okay. So my name is Ishay Green. I'm the CTO and co-founder of Spot.IM. Besides of being an entrepreneur, my real profession is a software architect and a programmer. So I'll start with explaining what Spot.IM is doing. We started Spot.IM in the idea that we want to create another social network in the world of Instagram, Facebook, and it's crazy and it's stupid, but this is what we wanted to do. And the first thing we had to solve in order to build a social network is attention. How do we get attention? And we got to the conclusion that the internet itself gets a lot of attention, which is websites. So we started building a social network for websites, and we got to the conclusion that talkbacks and comments, like after 3 spin-offs, that this is the entry point to the publishers. So currently Spot.IM is around 4 billion page views, and it's growing very, very fast. And our main data store is Redis. I'm going to show you the product, and then we're going to talk about Redis, and I'm going to show you actual stuff and ask you questions. And so everyone knows that beneath any article in the internet, you have like people trashing each other, which is called the commenting system. So this is a website that calls The Drive. It's a website that belongs to Time Inc. And we created a community under The Drive. It's people that like cars, weapons, and missiles and stuff like this. So what you see is that we have this component, which is a component which is popular in a community, and people use this to find stuff that is interesting. Just a few points. When publishers put Spot.IM on their website, the time on site goes by 10%, more 10% in time on site. It also generates revenues. Our company is almost profitable, and it's growing. So let's get to the point. So what is Redis for me? Okay, so when we entered this project, we assumed that we're going to succeed. And if we're going to succeed, we're going to need to be very, very scalable, okay? We need to scale to the size of the internet. Now, the internet, there is what we call the other web, which is outside of Facebook, Instagram, and these silos. And the internet itself is bigger than Facebook, Instagram, and all of these ones, okay? So if we want to be everywhere in the internet, we need to hold this. And I was influenced by the architecture of Google, which is in memory, okay? Every time you search in Google, everything returns like in the same, it doesn't matter if it's a complicated question or a stupid question, okay, Google returns it immediately because everything is pre-searched and saved in memory. So in that sense, I said, okay, I want an in-memory database, and I'm going to deal with the price later of the hardware and everything. So I looked at Memcache and other stuff, and then I encountered Redis. And the first thing I saw in Redis is this amazing, amazing website. You know this website? This is an amazing website, and I was shocked, okay? Because immediately I understood that this is a mathematical way, a mathematical database, okay? Through sets, sorted sets, numbers, timers, okay? You can take any key and put on timer, and it's going to die magically and going to free the memory. And all these things, I said, okay, how do I use this to model a full database? And I'm going to ignore the fact that there are Postgres and SQL and other databases. And we actually did this. So let's look again on the product, and I'm going to ask you a question. And someone is going to need to find the answer, because I didn't find the answer. My software architect find the answer to the question that I'm going to ask you, okay? So look here. So we have a conversation. So how would we model comments and replies? So this is the first question. I'm going to answer it, and then the hard question. So you have a sorted set, okay, that holds all comments, okay? And for each, for each comment, you have another sorted set for the replies, okay? And it's like, you have a sorted set for newest, okay? You have best, which is like some kind of score. No internet, never mind. So you have best and you have controversial. We removed controversial because it's always like really nasty. And we use this as a sorted set, okay? Now, we came, like the Drive and other websites said, okay, the 2 level is very nice, but we really want to talk about missiles and weapons, okay? So we need to be Reddit style, okay? So I gave a challenge to my software architect, Yaron. He's a genius, okay? And I told him, you need to do this to make it like multi-level, and every website can configure how many levels he wants, okay? So some site can choose to be 6 levels, some sites, do you understand what I'm talking about? Yeah, like Reddit. Replies that goes like deep. So he said it's going to take like 4 weeks. I said, no, you have like 3 days. So he thought about 10 minutes and he said, I have a solution. So how do you model? Okay, it's like almost the answer, but how do you solve this? Someone. How do you take, and you need to be backwards compatible, of course. What? No, we don't want to rewrite all the system, okay? So this system, by the way, it's 250,000 lines of code, which written in Ruby. Later I'm going to show you stuff about latency and about performance of this science fiction database. We don't rewrite the system. You need to finish writing it in 3 days. If he's going to add these layers. So I'm going to say like the next step to the answer. So he asked me a question. He said, okay, I found the solution. He said, how do you model in a sorted set, okay, a tree? That's it. And you have the solution. How do you do this? No, that's the numbers. Okay, so imagine that you have 1, 0, 0, 0. And under 1, 0, 0, 0, because it's a sorted set, it's numbers, okay? So you can model a tree inside a sorted set. I don't need to explain like the details, eh? Okay. So that's it. So it's going to take him like 3 days, and it's going to be backwards compatible because now it's by time. So the only thing that we're going to do is just going to add to the numbers the sorted set. And what it turned out, okay, and we find it time after time with Redis and with the power of Redis, is that everything we want to do with this system after we created a very good framework to work with the databases of Redis, that it's very, very fast. Okay, it's very fast and very easy to do migrations and stuff. Like, for instance, one thing that we have in the system, you talked about the doctor. So we have doctors that run on the memory, all the time on the memory, on stuff that we think that could have problems, and we just fix them, okay? So the system is really tolerant because though Redis labs are amazing, okay, and they have 0 downtime, yeah, and they have like their DevOps are the best in the world and very, 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 very like amazing. It's like they are a very good team. Sometimes there are glitches, sometimes there are problems. Sometimes they say to you, I need to disconnect the database for a second. And in this second, stuff happens, okay? And also in code, like our servers, they crash in the middle of transactions and it's not transactional database. So the way that you need to treat the database is that everything can break there. Okay, it's not a hard system that, you know, if you have a problem, someone dies. It's just people trashing, you know, Bibi or stuff like this, so, or Trump. So it's not that, you know, in that sense, critical. I'm going to move to the next point. This is how many databases we use. So what we do with Redis, we implemented microservice architecture, okay? And it's like a buzzword, microservice. And this is why I like to say microservice. But how does it work? Actually, what we did, we have for every task, we have a database, okay? For instance, we have a database for porn, okay? For porn, it means like every pornographic website that someone submits to Spot.IM and it's recognized it as pornographic, it's saved here, okay? We have prod rank, okay? So every time someone ranks something, like does like a like for something, it's saved in this database, okay? So you can see that this database is 69 gigabytes from the day we started, and it's like, you know, we have just in AOL.com, we have 500,000 likes a day. Maybe I can show it. Okay. So all these likes and dislikes are saved in this database. Let's talk about latency, okay? So our microservices are implemented in 3 languages, okay? Ruby, Elixir, and Node.js, okay? The one thing that Redis allows us is when we run Ruby, people would say, okay, you have like 200, 250 milliseconds per request. You're going to have like tons of servers. But because Redis responds in sub-millisecond on some queries, and if you do the queries right, okay, and if you understand what you do, and if you know how to parallel, okay, your requests, it gets very fast, and our Ruby servers, microservices servers, respond in 30 milliseconds, 40 milliseconds. So you can use, for one hand, a language which is very, very strong in its like ability to be descriptive, and it's built to describe a social network. It's if you are a programmer of Ruby, and from the other hand, enjoy the short latency. The same with when we work with Node.js and this system. Let's talk about elasticity. Okay, so the internet, when you are on AOL.com, on Little Things, on Deeply, so like Little Things itself, it's like 500 million page views a month. Now, if you have a website which is 500 million page views a month, sometimes there is like a really, really cute baby and an article about this baby, and it gets viral. And when it gets viral, it can get to few millions of people hitting the website simultaneously. And when they hit the website, they load our JavaScript from a CDN, which in turn shoot a request to our Amazon AWS through Akamai, gets to our servers, and then hits Redis, like 5 to 10 different databases in Redis, build a response, which is called all, a single request, and then returns what you see on the screen, which is the comments and the user take, because each user did like on something, so you need to draw like his own likes. It needs to find the user token. It needs to run many, many stuff. And it has to do many round-trip requests to a database. So if it was a database which would not be as fast as Redis, it wouldn't be feasible for us to do this. You understand? Because I need to check, is this the user? He has the rights. Give me the take of the user, give me this, give me that, ta 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 ta. All these requests would take a lot of time, and it wouldn't be feasible. So what happens? You get like a hit, and you have like you need to scale up fast. So one thing that I never care is what is going to happen to the database, because the database is like, and we're going to talk about the clusters that we have in Redis. It's like on like I think something like 10% CPU. So let's say that we get like huge traffic, so it jumps to 15%. Okay, it doesn't feel it. Okay, like my database doesn't care about this baby. It doesn't care. Okay, and if I had, and the only thing we had to solve is the scalability of AWS. So one thing that we did with the Redis Labs guys, and this is while running these experiments, we crushed Redis a few times. What we did, we alter the Redis library inside Ruby. And what we did, we allowed it to open like endless connections, okay? Because not a single connection. And what it allows Ruby is like, if you really run Ruby in a multi-threaded manner, okay? You are not waiting for the connection pool. And what it caused that if you're going to look at our databases, the amount of connections, it's not typical in, let's see this database. Okay, this is database, you don't have many writes. Okay, this is all spots. A spot is like a website that joined Spot.IM and created a spot. So it's a database that doesn't have a lot of requests. Reads per second, it's nothing. This is about elasticity. Now, the number one thing that we worry about is what's going to happen if the computers are going to just, turn off. So if you have like a database like Postgres, it's all on the hard drive. You turn it off, you turn it on, and I don't know. You keep like few servers, and the storage is like separated from the machine, and you don't really worry about what's going to happen if it's going to shut down. In Redis, it's like it's my nightmare, and this one thing we are solving right now. So what we did is that we assume that Redis could, I don't want to say it, I'm afraid from it, okay, could be turned off, okay, and have a problem. It doesn't happen because of Redis Labs and because they are very, responsible and like take care of our servers, but it can happen. So what we do to protect our system, we use lies. How do we do this? One thing that we do, you see this? What we do with this, we use what is called CDN stale content, okay? So we took a very cheap CDN, not very cheap, a medium cheap, Edgecast, and we connected Edgecast to Akamai. We configured in Akamai stale content. Akamai gets this thing, the pre-render of this from Node.js, which in turn queries the Redis. Now, if AWS dies or Redis dies, what happens? It's going to get 500, the Akamai. And Akamai serves stale content to the cheap CDN, and the cheap CDN is going to make us rich. Okay? Now I have the same problem here. Okay? What I'm going to do with this thing, if someone, so we have like millions of comments people are trashing every day. So, and also talking about important stuff. And anyway, so I need to keep this live. So I don't have a solution. If someone has a solution, we can talk about this later. But one thing that we are adding right now to the system is just having a backup to the Redis in a form of S3. So in case the front end make the request and it's fucked, so it gets a request to the CDN and it downloads like the last conversation that was serialized. Price. So when you take Redis as your main data store, you have two things to deal with the price. One, the hardware that you need to pay to Amazon or wherever you run. And the second thing is the service to Redis Labs. So in order to solve the problem with Redis Labs, you come and lecture and you ask nicely and they give you a little bit of a discount. And the problem with the hardware, they are working very hard in order to upgrade the hardware. So what we're doing right now, Amazon finally released the X1 machines. You know the X1? You know X1? So what what is going to happen, all our cluster, which is like something like, I think, 15 machines right now, or 14 machines of R3 and whatever, is going to be replaced by 4 X1s. So we did an experiment, and we had the problem, and we reverted. We did a failback, and now Redis Labs is working in order to do this, and this thing is going to shrink the price to third. Okay, so the same hardware is going to be third, and it's very good to me, this thing. So this is about price. Another thing about price, and this is like the future of how Spot.IM looks at Redis. One thing we'll need to solve is like every comment and every stuff, everything that people say is saved in memory database inside Redis, and it looks reasonable 2 years ago, and now it's like it costs money, and the databases are growing. It's not really big yet because it's only text. Okay, it's not. I don't save images, binaries inside or videos inside Redis. But what we have designed is a thing to do actual offloading to a different database, just the strings. Okay, so the indexes will always be in Redis. Okay, and we're supposed to be profitable enough to pay for this. I'll just sum up. Yeah, I'm fine? Okay. So, along the years, I always ask myself, what are the mistakes that I made when implementing my system with my architecture? And sometimes Redis looked like it was a big mistake. But I can tell you now, when it's been years working on this, and again, it's very, very, it allows us to work very, very fast and not to be sensitive on stuff like scalability. And it was like the best decision that we took in our architecture. And if someone here is, I don't know, thinking about alternatives, I wouldn't go for it. Like I would go for Redis, not for every task, but for a lot of mission critical, like very, when you need low latency and complex systems. Okay, that's it. Thank you very much.